Hi everyone. Today an example solving for the acid equilibrium constant as well as percent ionization. Here's our question. Propanoic acid with a concentration of 0.10 moles per liter was prepared and found to have a pH of 2.96. Determine the acid equilibrium constant, Ka, and calculate the percent ionization. It's important to say once more that this is actually an icebox question. The solution was prepared, it was set up like this, and then it was found later on to have a certain pH, to have some certain equilibrium conditions. We could take our time and work through the full icebox. However, there's a much more efficient way to go about solving these questions. When we're asked to solve for the Ka, I have this modified version of the formula. The acid equilibrium constant is equal to 10 to the power of the negative pH squared over the concentration of the acid initially, subtract 10 to the power of the negative pH. I have all the necessary values given to me here in the question, so I can just move forward and start to substitute them into my work. The acid equilibrium constant is 10 to the power of the negative pH. And look, it is. Look, there it is right there. The pH is 2.96. So here I have 10 to the power of negative 2.96. That's going to be squared. This is divided by HA, the initial concentration of the acid, propanoic acid with a concentration of 0.10 moles per liter. There's that concentration, 0.10 moles per liter. And we're going to subtract 10 to the power of the negative pH. Subtract 10 to the power of negative 2.96. Now all I need to do is calculate that. I can take my time. Depending on your comfort level with your calculator, you might be able to go through all of that in one step. If you have to break it down, you can do that. The point is, we can go straight from the question to the answer and bypass the icebox. So I have 10 to the power of negative 2.96 squared divided by 0.1, subtract 10 to the power of negative 2.96. Now I get 1.2156 times 10 to the power of negative 5. There's my raw answer. I can go back and look at the question. 0.10, that has two significant digits. A pH of 2.96 also has two significant digits. So I want to round this off. 1.2 times 10 to the power of negative 5. And equilibrium constants, like pH and pOH, don't have units, so we made it to the answer. We have the follow-up question. Also calculate the percent ionization. Here I have this version of the formula. The percent is equal to 10 to the power of the negative pH over the initial concentration of the acid times 100. It's a percent. Importantly to note, once more, here the numerator is being squared. In the percent calculation, it's not. In the denominator for Ka, we had this subtraction. In the percent calculation, we do not. So we move ahead. We have 10 to the power of negative 2.96, 10 to the power of the negative pH, over the initial concentration of the acid here was 0.10 moles per liter. I'm going to multiply by 100. And I do that calculation. 10 to the power of negative 2.96 divided by 0.1 times 100. 1.09 6478196. Again, thinking about the significant digits, as with our work with the Ka a second ago, we have two significant digits, so this is 1.1%. When we're asked to solve for the Ka, we could work through the full icebox. It's such a time saver to use this version of the formula to bypass that. We have to be a little bit careful. We can't forget the square. We have a little bit of subtraction down here. There's lots of demands upon our calculator usage. However, we can do it all in one step to calculate the Ka. There's some important differences between that calculation and what we'll do with the percent ionization. We do not square the numerator here. There is no subtraction in the denominator. We can't forget to multiply by 100 to arrive at the percent. And I hope that helps.